Artificial intelligence is rapidly reshaping industries worldwide, and power utilities are no exception. AI is being applied to grid operations, customer engagement, cybersecurity, and infrastructure management, driving efficiency, resilience, and modernization. And with all the AI buzz, many utility leaders are asking, how do we actually apply AI in grid communications? What are the tangible benefits? And how can utilities prepare for the transformation? To help us better understand these questions, plus understand the critical role of AI in telecommunications, we are joined today by two experts from Nokia to break this down. Dominique Verhulst is the global energy practice leader and has been at the forefront of networking and digital transformation for utilities. And Hansen Chan works in IP enterprise solutions marketing, bringing his specialization in AI-driven network automation in digital industries. Together, we will discuss the real-world impact of AI on grid communications, the challenges utilities must prepare for, and the role of mission-critical networks in enabling AI-powered operations. And as a note to our regular listeners, I'm happy to note again that in 2025, we have video accompanying this podcast. I recommend you check out the show notes for the link where you can now follow Power Perspectives on YouTube and watch these interviews. I'm Jason Price, your host, coming to you from New York City. And with me, as always, is Matt Chester, Energy Central producer and community manager from Orlando, Florida. Matt, AI is one of the hottest topics in the Energy Central community right now. What kind of conversations are utilities having about AI adoption?
Yeah, Jason, you're right. AI is definitely a major focus in the energy industry right now. And within our Energy Central community, we're seeing a mix of excitement and cautious optimism, I would say. Utilities are exploring AI for everything from grid optimization, predictive maintenance, to improving customer engagement, cybersecurity. What's clear when you read between the lines of Energy Central members discussing AI is that while it has a potential to revolutionize how utilities are operating, its adoption needs to be done strategically. It needs to balance innovation with the critical priorities of reliability, security, regulatory compliance.
So thanks, Matt. Before we dive in, we'd like to thank Nokia for sponsoring today's episode. Now let's get started. Dominique and Hansen, welcome to the Energy Central Power Perspectives podcast.
Hi, Jason, Matt, pleasure to be here.
Yes, thank you for having me.
Fantastic. Well, we're excited to have you here. So let's start with the conversations and let's get going. So artificial intelligence dominates the headlines. AI brings threats, opportunities, and most of all, the unknown. Everyone seems to be discussing where is AI heading and how do we as a society embody this profound new technology. So let's start with the basics. How do you define AI and what makes this technological movement similar or different? Dominic, why don't we start with you?
All right. Well, Jason, AI is basically just simulation of human intelligence in machines or computers to do things that normally would require cognition, right? So this is really based on learning, getting a lot of data in to understand what is kind of normal behavior or not normal behavior, and then use that in different ways to either do problem solving or do assistant decision making or predicting certain behaviors. So, this is really the core of AI and how it's being used. So maybe Hansen, you want to add a few things to that as well.
Yeah, thanks, Tom. I think from the perspective of an engineer, I see like AI represents a new approach to implement systems from both software and hardware perspective. Some people call AI actually software 2.0. So in software 1.0, where we use C++ or Python or whatnot, right? So the human programmers will code everything by themselves, from the algorithms, from all the value of parameters to everything. You code by the human programmers. But in AI, right? So I think the paradigm is that so we let the data speak. We let the data actually even write the software. So, in simple terms, right? So, of course, you still need programmers to prepare the data set that Dominique was referring to. You still need the programmers to actually, write the code to about the model of the AI model. But the essence of the model, which are the parameters, billions even going up to 1 trillion of parameters for those large language model, AI model, right? So all this would require, right, data set to fit in, and data set will actually determine what are the optimal value. So instead of human programmers trying to decide and determine. And from the perspective of hardware, it represents a migration from CPU-centric compute platforms to a GPU-accelerated compute node, right? Meaning that GPU now plays a major role of doing all the computation, because in AI, especially in the AI model, like the one that we are talking about most, all the time now, transformer model, neural network model, they're all represented by layers of neurons, and they are represented by matrix. So, and in AI processing or inference and training, so a lot of matrix multiplications are required. So it requires, a parallel computing platform, which GPU was designed for in the beginning to process video, right? So it represents a shift from a CPU-based compute node to a GPU-accelerated compute node. I think that, so this represents, how AI is actually changing, the way we implement, technology systems.
You asked, how is it different or similar as a technological movement? I would make the comparison to like the mid 90s, when we started to see the internet come up and become popular. And we had imagined certain things to happen. And there was fear that, this would eliminate jobs, that there would be all kinds of problems coming out of it. And for sure, there's things we need to think about ahead of time and we'll talk about that a bit later. But I see many similarities, with people thinking about how is this going to affect our daily lives? Is it going to take away jobs? Is it going to create more risk or unsafety or whatever? And we're really at a next level of that right now. And I think that what we experienced back in the mid 90s till now, we're going to see, a lot further evolutions of those models being put into practice. And it's going to create new opportunities. It's going to create new businesses, new capabilities, and it will enhance ultimately the way we live, and also are going to be able to manage grids and networks. At least that's my take on it.
Yeah. I think that's very good. That's good context. Whenever there's a new technology, there's always the extremes on both ends, the opportunities, but then the potential threats. And it over time, as we understand it more, industry adapts, people's skills adapt, marketplace adapts, and then it becomes part of the mainstay. All right, but let's do this. I want to go back to Hansen, because you said some things that were interesting, and I feel like it's the logical next step, and that is really around AI and its benefits, particularly as it relates to the utility industry. So I'd love for you both to answer it. Hansen, let's start with you, but share with us, what are some of the specific ways AI is benefiting power utilities today? Where do you see it eventually moving to in the future? And also, talk to us about what you feel, and again, both of you, but start with Hansen. What are some of the guardrails necessary to ensure that it's successfully adopted?
Right, very good questions. And I think we have to recognize that like AI is not really new, right? In industries, or in utilities in particular, right? I think go back to 20 or more years ago, right? There have been a lot of research done using what we call machine learning, which is a branch of AI to help with grid operations. So it is not really new. So I think some of the low-hanging fruits I think we can see is that in the field of computer vision, where AI can help to identify patterns or some images, like whether this is a drone image, inspecting utility poles to see whether any poles are in a condition that need to be repaired urgently, or CCTV camera to prevent intrusion within the substation perimeter. So those AI technologies, I think, is quite well established. Right? I think those are the things that utilities can embrace and evaluate to enhance the physical safety of the electric grid. And moving forward, I think we also see, with utilities doing a lot of grid modernization and digitalization, meaning that there are more and more digital data from the grid, from deploying AMI system to a single phaser phase measurement unit, PMU systems to power quality meters. So there are more data available. Utilities can use to capture some trend in the grid, so that they can take some early action or preventive action before anything goes wrong, right? And also, I think some of the things also we have to be aware or be cautious when we deploy AI is that, there are quite many things, but I can probably highlight three. So one is to understand how AI come to this, prediction, how AI come to this decision. So to understand what is the train of thought, what is the train of thought in the AI model. So instead of letting AI to operate as a black box, we need to understand, right, how to be able to explain and interpret what AI says. I think secondly, also we need to be able to validate what AI says. Is there a way we can validate that and test that? Perhaps leverage the use of digital twinning technology. Instead of trying this in the real, working grid, to do this in a digital twin or of the grid or of a certain transformer and simulate that, right? And then the third one is also security, which obviously is a wide topic, whether the model should be open and transparent, whether it is developed in-house or some open source model that you can look at and scrutinize and also scale and optimize for your own domain, right? So that everything is being deployed inside your data center and IT infrastructure, right? Instead of exposing anything towards the public internet. I think these are the three things that probably need to be considered among others.
Yeah, I think like utilities will benefit from AI today, and they do already, like Hansen said, because there's so much more data coming from the different assets in the power grids right now due to the digitalization, and also because power utility has been forced to bring in a lot more renewables. We've got a lot of solar panels on rooftops. We have a lot more renewable energy coming into the grid, and those assets typically are modern assets that are equipped with newer technologies. They're completely digitalized, so we can get a lot more data from them. So it is therefore becoming easier to do better demand forecasting and load balancing with all the data that we have. The trick to unlock more is to get more data from more assets on a wide scale. So having better distribution automation, having much more tightly integrated digitalized assets across the grid from generation all the way to through transmission and distribution is important. And I think that AI will also provide the grids with better tools to assure grid security and to detect potential threats ahead of time or unlawful activity on the grid ahead of time. And that's the benefits that AI will bring. But I agree with Hansen very much so that regulation is going to be essential to have fairness in the system, to have safety embedded with it. And you have to find the right balance between, innovation and, how much you're going to be regulating, right?
Okay, I want to ask you both about AI and data centers. As we know, data centers are driving massive new energy demand. Talk to us about how is this shift impacting grid infrastructure, but also address it in the context of grid communication infrastructure. But maybe, Dom, you want to start, and Hansen, you feel free to follow.
Yeah. Well, AI, depending on whose analysis you're looking at, the adoption of AI in the industry or in the world in general means that our classical data centers, when move to AI, we see a increase in demand of power that ranges between 50 to 300%. So that's big. And the load is more how should I say, variable. It's not like a constant load. It actually changes a lot depending on, how much activity there is. So the focus is going to have to be on strengthening the grid in terms of availability and providing more power these AI enabled data centers. So peak load management stability is a problem that we need to fix, because we can bring renewables into the mix of that, but renewables aren't always available. I mean, they're not always very predictable in the long term. They can vary quite a bit. What we see, and probably Hansen can give a few examples of that. Also, nuclear plants are being looked at as an alternative source. So we see this trend both in the U.S. and in Europe, where people are thinking about maybe, nuclear can be the kind of stable bulk power generation system we need to enable the system with AI at a large scale. But again, as I said, this is going to have to be balanced with renewables in a way, and we'll have to find better ways to secure frequency stability and availability of the grid. But nuclear is obviously a good way of doing that. And there's examples of contracts that have been renewed in the U.S. With nuclear facilities to help the likes of Microsoft and Google to do exactly that.
Yeah, in some of those discussions that I have had, with utilities, right? I think one of the topic that they brought up, is that, a lot of those, companies, especially the hyperscalers, right? They are now coming to the state or where they operate, where the utilities operate, and ask for, 150 megawatts, 300 megawatts. Right, so it's become really a challenge, right? All with this extra loading, right, on the grid. So this is really due to the fact that a GPU accelerator node consumes much more power, and the fact that for AI to work, in a high performance way that generate excellent outcome, right? To become better and better, right, to perform better and better, you need a bigger model. And that means you need more GPUs, you need a more compute node, and then you need bigger data centers. So this is really, really causing a lot of headaches, right? So, as Dominique said, right, those small nuclear reactor technologies are being looked at, right? And then to provide a very stable base load, and then complemented by renewables, right? Maybe I can also talk about how does AI affect the grid communications, especially when utilities themselves are embracing AI and host AI models and AI hardware, in their electric grid infrastructure. So one thing, quite unique with AI workload communications is that they are intolerant of any transmission loss compared to other applications. This is due to the fact that AI workload is very distributed, meaning that they operate across a cluster of GPU accelerated nodes. And then all the memories and multiplications and operations of those number, which are actually matrix multiplications, are distributed. So, and then they've done that in a parallel way, meaning that, if there is communication problem in the network, it will slow down. So it's like, you have a powerful F1 Formula race car, and then you drive this, on a bumpy, muddy road. You totally, slow down your Formula One race car, right? So for AI to really perform, right, and to be able to train your AI efficiently, you need to have a grid infrastructure, communication infrastructure that is resilient, that's reliable and high performance, to complement, right? Otherwise, all the effort and investment you put into AI, right, into IT infrastructure, you cannot really get the best out of it. I think the network security is also important, as all the data are being transported in the network for AI to consume, and for AI model to be trained on. So the confidentiality of the data is required. So I think so that's why with encryption technology is needed, And now with the imminent threat of quantum, computing, cracking existing public key algorithms, it's important to also look at the use of quantum safe networking technology to encrypt your data for AI, influence and also AI training. So this is another aspect that we cannot overlook.
Okay, so Hansen, you brought up twice now security. That's a very important topic. You talked about threats. You called that out. So let's switch gears for a second. I'd love to get your opinion, both of you, on DeepSeek. So this only was announced, I think, 2.5 weeks ago. I feel like we've since then learned that, perhaps it was more expensive than what the original quotes were given in terms of how to develop it. The quality of the AI has been now suspected to be less quality than first originally stated. But regardless, DeepSeek is changing the norms on how we're viewing AI, particularly from a computer processing and power planning standpoint. So are you surprised by what we learned? How does this change the strategy at Nokia? Just basically, what's your general impressions of that? Dom, you want to start?
Yeah, it's a good point, and definitely something we looked at and really embraced, because I think what it does is it puts things back into perspective. And what it does, it says that the lesson learned here for me is, we're moving to an open source large language model kind of AI, which can be on-prem rather than in the cloud. And why is this important in this conversation is that, this kind of AI LLM technology, having that capability on-prem for utility is critically important, I think, rather than having something which is completely cloud-based where they have no control of. Here, if it's an open source model, and Hansen actually referred to it earlier as well, if it's open source, you can actually have a lot of checks and balances on, how it makes decisions, how it learns things, how it evolves as an AI model. And having this capability on-prem inside a utility is I think, very good, because it can assure them of better control, enhanced cybersecurity, etc. And the good news, of course, is that this is driving more demand in terms of data center networking and CPUs. So I think it's all in all, I see this as a positive evolution to put things into a different perspective, which is going to be good for our industry, by the way.
I want to now bring this back to the utilities. So, there's been such a convergence over the past few years where you've got the IT and OT coming together to run the grid in a much more unified way. So love to hear from both of you around how is AI reshaping how utilities manage optimizing the network. To power and run all this requires communications, right? So underlying, the systems to talk to each other is the communication component. So maybe take a moment, both of you, I'd love to hear from both of you, just basically, how is AI transforming all this? What are you seeing out there on the landscape? What kind of conversations are you having? And anything you can share from that perspective.
Well, I think it's not just AI that is transforming this. I think the grid transformation has already started some time ago, where we saw the need to do better distribution automation, to use digital twins in the protection, automation, and control domain of grids, where you can actually model the way your protection automation is working, and you can then, depending on, which changes you want to make, you can do that in the model and then try that out before you go and deploy that. And in distribution automation, we also see applications like fault location, isolation, and service restoration. We call it FLISR. And you can only do that unless you have a lot of data coming from your assets, and you also have a strong communications infrastructure fabric across all of these assets in your power utility substations, but also in the wide area context, and feeding that into your operational data center. The technologies that are enabling all that are technologies that we have known in the IT space for quite some time, and were less used in the operational telecom space of utilities, for the last, couple of decades, I should say. And now the industry is catching up with that. And what we do see is what you mentioned earlier, Jason, is that convergence of OT and IT, not necessarily of the networks, but of the technologies and the talent and the people that we see power utilities needing to manage their grids and their communications networks. They're becoming much more similar to each other. And there's a lot of things that the operational people can learn from the IT teams. So I think that's a very important change that we see in the utility space as they are preparing to embrace AI and bring AI into their operational domain of the grid.
Yeah, I think the term IT OT convergence has been around for many years. I think different utilities have on a different stage in that convergence journey. Some are faster, some may not be as far off, right? But I think one thing that is common to all utilities, I think, is that all the new digital systems they are deploying, right? So introducing a lot of IT technologies, right? From the way like software is being delivered in a software-centric system to a lot of the OT compute technologies, right? Whether this is based on virtual machines or even containers for some less critical system software. So it is, I think, really natural that those systems can evolve to embrace AI component to make the software runs better, to be able to unlock the potential of all the data of just, as example, instead of just detecting whether certain measurement cross the threshold, you can also allow you to identify the trend, whether this is approaching or, this is, or decreasing from the threshold, so you have a better insight, right? Instead of a very rigid, crossover, crossing, right? You get an alarm, so you can get an alarm, or to understand, when there is something, continuously, fluctuating, in the measurement, right? So does it indicate any problem that you have to investigate early on, right? So it gives you a better insight, right? And also with the AI component in the system, you can also allow the staff to overcome the learning curve of a new system, or allow a newly recruited, an expert to get on board much quickly, right? Instead of learning with all these intricate, a graphic user interface and commands, right? So with AI, with Gen AI, so the staff can actually get to work with the systems right away and employ their expertise, right? Instead of spending all the time trying to learn how to actually navigate the system.
If we can, without naming names, it would be great to hear examples of utilities that are out of the lab, out of the pilot, and are actually integrating some of the things we've been discussing. So are we there yet? Have you seen it? Can you share what's the nature of the types of projects that AI is being integrated into?
I think it's still early days, but I think that there are utilities already out there that have integrated some elements of AI into their demand response and grid automation in terms of predicting what the load is going to be in certain areas at certain moments in time, by integrating data from weather systems, etc. So I think that some of it's already been done in quite a few utilities, certainly in North America and in Europe. Whether we call that AI or whether we call it, machine learning based kind of algorithms that are being deployed to improve that kind of availability and predictability of the grid, I wouldn't dare to say. But of course, there is certainly a push towards digitalize more, having more data available at the source, being capable of doing a lot more with that data in a local context of a power station and between power stations and control centers. And that is currently where most of the effort is going, I think, is to really start to digitalize that infrastructure and getting rid of legacy systems, getting a more consistent way of reaching all of the power generation and distribution assets across the grid with telecommunications. That is certainly going on. We've seen examples of that in the US, in Europe, where power utilities are using private wireless networks, or they're using fiber networks, very granular fiber networks to the home or to the substation, to be able to bring in more intelligence about how they make decisions of managing the grid and predicting the behavior of the grid, and put production against demand at any moment in time to keep the grid stable. But I think it's, to answer your question, Jason, it's already happening. Whether we want to put the big AI sticker on that to say this is AI, I don't know. I don't think that people would say that. Maybe you have a different view on that, Hansen.
I've seen examples of use case that utilities are very interested in, which is outage protection, especially these days with the climate change, a lot of weather systems, hitting different areas. So it's important for utilities to be able to know the risk of which areas of their service territories are most vulnerable to a certain weather event. So with past weather data, and also past outage data and weather forecasts, and also geospatial information such as vegetation and the density of households. So they can use AI to help to map out the risk of different areas for a certain weather event that is coming their way. Now they can plan to deploy their workforce right at the right locations. And then according to the criticality of different areas, and so that they can really reduce, the failure or the outage time affecting the least number of households, and protecting critical facilities such as hospitals or whatnot. So that would really help them. So I think this is something that I've seen, utilities and also different system vendors, suppliers are working together, right, to make this more commercially available.
Yeah, I agree. I feel like that is one of the bigger opportunities here. I mean, a lot of utilities are moving away from the fix on failure, right? So having that ability to plan and using predictive analytics and using AI to help identify where the soft points are when the storm comes through, they're already able to plan ahead of time and reinforce some of those areas. So if I may, I want to ask one more question before we get into the lightning round. So the question really is around what do you feel are some of the biggest trends in AI for the power sector over, say, the next 5 to 10 years?
Well, I mean, there's a long list, but if you want me to say what I think is going to be the biggest trend with AI in utilities, it's automated grid operations, where AI is going to be used for, voltage control, frequency regulation, fault detection, reducing the need for manual interventions, really automating a lot more the use more of drones and robots to run inspections that can be, to take pictures of power lines, poles, etc., to feed that into the model, as you said earlier. Based on that information, when a bad weather event comes in, you may have a better idea of where a certain failure may occur ahead of time. So I think, automated grid operations would be my number one for what's going to be the biggest trend in AI for power utilities.
I agree. But in addition, I think the outage would be another area that would really help utilities to provide with more reliable quality power to their customers.
Yeah, I totally agree on that. I think there's a lot of gain there. All right, so gentlemen, we're now approached what we call the lightning round, which gives us an opportunity to learn a little bit more about you, the person, rather than you just the professional. Okay. So we're going to throw a bunch of questions at you. Don, why don't we start with you, then over to Hansen, and we'll follow that pattern. So let's start. So you both work for Nokia. What kind of mobile phone do you use, if you're allowed to reveal?
I'm happy to reveal. I'm using an iPhone.
Yeah, me too.
Okay, back to you, Dom. What is your favorite way to spend a day off?
Well, a day or a week. If it's just a day, then my favorite time to spend the day off would probably be on a motorcycle. But yeah, that would be the day off. If I have more time, it would be probably spend time in Italy. Yeah, that's my favorite pastime.
Yeah.
Right, Hansen?
For me, for one day off, probably I'll be more a homebody, listening to classical music and reading on books, to spend the day.
Sounds nice. All right. So, talking about AI, what's your favorite movie that has dealt with artificial intelligence? Don?
Well, actually, I don't have to think long about that one. The favorite movie that still sits in my brain is like the 2001 Space Odyssey of Stanley Kubrick. I thought that was a mind-blowing movie when I think back at that movie, which actually was shot in 1968, believe it or not.
Right.
So
Right.
a very long time ago. It's amazing.
Right. Given this topic, you're making me want to go back and watch it again.
For me, I would say Terminator 2 in particular.
All right. Who are your role models growing up?
Wow. I would have to say my dad as a kid when I was growing up, because I really looked up to him as a person and how he was able to, fluently converse in 3 or 4 different languages. I thought that was very inspiring, and I wanted to be at least as good as he was. And then later on, when I grew up and started to get interested in electronics and computer science and so on, then Jobs and Wozniak were my heroes back then. Yeah, that would be my role models.
For me, my high school hero would be Richard Feynman, who is the founder of quantum electrodynamics. So I was, introduced to Richard Feynman's books by my high school teachers when I was in grade 10. And then from that time, I start to, be mesmerized by quantum physics.
Okay, nice. All right. So we also collect lightning round questions from past podcast guests. So I'm going to ask you both a question that came from Adam Rayfeld of Burns McDonnell. You're both going to be at Distributech in a few weeks. What are you most looking forward to learning while you're there?
Well, I would love to see how the industry is advanced in terms of adopting new technologies, in particular, of course, the telecom part of it, how IP and Ethernet and protection, automation, and control is evolving, how the VPAC Alliance is doing, how the adoption of 61850 as a way to define substations and power utility assets, but also protocols is moving forward in the world. So I'm really excited about seeing how all that is evolving and where we are, from a year ago now.
Yeah, I think for me, that event is always an exciting place where, all the people, whether they are utility operators, system vendors, suppliers, consultants, all meet to share ideas. I think that what I would, be looking forward to is to learn any updates or advancement in the deployment of grid automation, particularly IEC 61850, and also the use of more the cutting edge IT technologies from virtual machines to cloud to containers into those systems to see what is the experience when they trial it, when they deploy it, and what we can learn from.
All right. So last question. It's really now your opportunity to ask a question to a future guest.
My question to the next guest would be, what would you see as the best way to assure the power to the AI-enabled world moving forward?
I think for me, what are the most rewarding and enjoyable aspects of your career in the energy industries?
Okay. Very good. All right. So thanks for indulging us with the lightning round. So given that and knowing you have an audience of utility professionals listening to the show, why don't I give you both the final word? What would be something that you'd want the audience to take away from today's discussion? Hansen, you want to go first this time and then over to Dominique?
Sure. I think with all this effort put into modernization from the grid system itself to communications and also the IP infrastructure, and also with more and more data becoming available, and also the compute is becoming also more affordable. So we see, I think we will see GPU becoming more affordable, energy efficient, and to be deployable in different locations. I think this is really the time to actually evaluate and understand AI. I think there is some some learning curve to do, but I think it's important for us, for all utility engineers, to understand how AI works, the power of AI, and how to use it responsibly. So I think it is really on us to make this happen.
Yeah, it's a matter of embracing it, not trying to push it out. I think, as I said earlier, digitalization is going to help us a long way. We're going to start to see the occurrence of more edge compute happening in power grids, in their substations. There's going to be a lot more IT-like technologies of virtualization that are going to start to happen all across the grid operations. So my prediction is that in the next 5 to 10 years from now, we're going to see a shift of, more taking intelligence out of specific hardware devices that people are using in grids for grid automation and control today. And that's going to be much more of a software-based function. And we're going to be able to do things more in an automated way because we will have so much more data coming from many more assets, potentially hundreds of thousands of places. So I think we're heading to a very exciting future where we unlock a lot of capabilities. And again, as Hansen said, going to have to make sure we put the guardrails in place. But I truly believe that for the open source models, the on-prem models of AI are going to be extremely useful for power utilities. And again, in terms of managing the telecommunications networks, we're already seeing AI introduced in many of the things we do see for network management, for automating certain tasks in the provisioning of services in the telecom network, for specific power utility applications, etc. So I'd say embrace it, don't be afraid of it, and it's all going to be good.
I cannot agree more.
Thank you for joining us today. Thank you for your thought leadership and sharing the insight with our audience. And I'm fully confident you're going to get a lot of questions. You can keep the conversation going on the Energy Central platform where people will post their questions, and we'll prompt you when the questions come in so you can respond back to them and stay engaged with the community. And thank you for today's sponsor, Nokia. Nokia creates technology that helps the world act together. Nokia is a B2B technology innovation leader, pioneering the future where networks meet cloud. And once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com, and we'll see you next time at the Energy Central Power Perspectives Podcast.